All right, here we are with the next lesson in Algebra 2. The lesson is called Writing Functions Given Zeros and Multiplicity. Okay. So, a few definitions to start. Some of these you should know already. Okay. First one is the standard form of a polynomial is when its term of highest degree is first, its term of second highest degree is second, and so on. Okay. Standard form. We talked about that in the last unit. For example, f of x equals x cubed minus 3x squared minus 28x. That's standard form. Once a polynomial is factored, it is in what's called factored form. For example, f of x equals x times x plus 4 times x minus 7. That is factored form. Okay? These are actually the same. Okay, these are actually the same. It's just that one is written in standard form and one is written in factored form. Also, recall a zero or a root of a polynomial is a number that, when substituted in for the variable, makes the function equal to 0. It's called a zero or a root. Okay, so example 1, this is going to be a fast problem. Given the following zeros, write a polynomial function in factored form. Okay, factored form. So it's going to look like this one. So this is the fast example. All right, so example 1a, I'm going to say f of x equals. If there's a 0 at negative 4, then it means x plus 4 is a factor, because when you solve x plus 4 equals 0, you get x equals negative 4 as a 0. Okay? If negative 2 is a 0, then it means x plus 2 is a factor, because when you solve x plus 2 equals 0, you get x equals negative 2. And if 1 is a 0, then it means x minus 1 is a factor, because when you solve x minus 1 equals 0, you get x equals 1. And that's the answer for that one. That is factored form. Factored form. Okay? Okay, so example 1b. If it has zeros at negative 5, 0, 2, and 7, write a polynomial function in factored form. Let's start with the 0 of 0. Since there's a 0 or a root at 0, it means one of my terms, I'm just going to put just an x. Okay, just an x. If there's a 0 at negative 5, then it means x plus 5 is a factor. Because when I solve that, I get x equals negative 5. When I solve the first one, I just get x equals 0. If 2 is a solution or a 0 or a root, then it means x minus 2 is a factor. And if 7 is a root or a 0 or a solution, then it means x minus 7 is a factor. And that's it. That's factored form. That's factored form, okay? Look above. Factored form looks like this. So that's factored form. So example 1, that's an easy problem. Just don't forget, you have to change the signs on those. Okay, example 2. You can probably guess what the example is before we do it. But giving the following zeros, write a polynomial function in standard form this time, okay? So in case you forgot what standard form is, look back at the previous page. Standard form looks like this. Okay, so what we're going to do is we're going to write it in factored form first, and then we're going to convert it to standard form, okay? So write it in factored form, just like we did in example 1. F of x equals 0. F of x equals x for the 0 one, times x plus 6 times x minus 3. Now what we're going to do is we're going to convert that to standard form. So basically you're going to distribute like crazy. Let's multiply x times x plus 6. Let's distribute that x to get x squared plus 6x times x minus 3. And now you're going to distribute again. X squared times x is x cubed. Then you have x squared times negative 3, which is negative 3x squared. Then you have 6x times x, which is plus 6x squared. And finally, 6x times negative 3 will be minus 18. And then it has to be in standard form, so make sure it's in descending order by the degree, and make sure you combine like terms. So combine these two like terms to get plus 3x squared. So f of x equals x cubed plus 3x squared, and then minus, this should be minus 18x right there, minus 18x. And that is standard form, okay? We combined all the like terms, and it's in descending order by the degree. X cubed, x squared, then just x. Same thing for example 2b. This one will be a little bit longer, actually. Okay, so here we go. First of all, let's write it in factored form. X plus 2, because the 0 is at negative 2. And then times x minus 3. And then times x minus 3 again. Because it's a 0 twice. 3 and 3. Yes, you have to put it twice. You'll see why after. Let's multiply the first two together and let's distribute. So x times x is x squared. X times x is x squared. X times negative 3 will be minus 3x. 2 times x will be plus 2x. And 2 times negative 3 will be minus 6. We've done this already. We did multiplying in the last unit. Let's combine those like terms in the first expression. Let's make that minus 1x. X squared minus x minus 6 times x minus 3. And now we're going to distribute again, okay? You're going to distribute again. X squared times x is x cubed. X squared times negative 3 will be minus 3x squared. Okay. Then distribute the negative x. Negative x times x will be minus x squared. Negative x times negative 3 will be plus 3x. Now let's distribute the negative 6. Negative 6 times x will be minus 6x. And negative 6 times negative 3 will be plus 18. Okay, so now let's just combine like terms. And let's make sure the final answer is in standard form. So we have 1x cubed only. Let's combine the x squareds to become negative 4x squared. Let's combine the x's to be negative 3x. And then plus 18 at the end. All right. So this next, before we get to this next major topic, we're going to be referring back to example 2b, because that's a good example. Okay. While the polynomial in example 2b has 3 zeros, look, 3 zeros. 1, 2, 3. It has 3 zeros. It only has 2 distinct zeros, meaning it has 2 different zeros, -2 and 3, because the 0 of 3 is repeated, okay? This 0 is repeated. 3 is repeated. So it has three zeros altogether, but it only has 2 distinct zeros. Only has 2 different zeros, -2 and 3. If a linear factor of a polynomial is repeated, then a 0 is repeated. A repeated 0 is called a multiple 0. A multiple 0 has what's called a multiplicity. Multiplicity equal to the number of times the 0 occurs. For example, in example 2b, the 0 of 3 has a multiplicity 2. Okay? The 0 of 3, okay, it occurs twice. So it means it has a multiplicity of 2. If this said -2, 3, 3, 3, 3, 3, then it would have a multiplicity of 5 because it occurs 5 times. Okay? We're going to talk about this more later, what graphs look like. So I'll save that till later. That's the last page. Okay, example 3, A, B, and C. Find the zeros and state the multiplicity of the zeros. So this is kind of like the last lesson that we did, lesson 1, solving polynomial equations, except now you have to state the multiplicity of all the zeros. Okay? So if you want to replace the f of x with 0, that's fine. 0 equals x minus 2 times x plus 3 times x plus 5 cubed. So think about it like this. You can probably go right to the answer, but essentially what we have is we have x minus 2 equals 0. We're going to have x plus 3 equals 0. And then we have x plus 5 equals 0, x plus 5 equals 0, and x plus 5 equals 0. Because it's cubed, x plus 5 cubed. So let's solve each one. X equals 2. X equals -3. X equals -5. X equals -5. X equals -5. You may recall me in the past saying when we solve a polynomial equation, the degree tells you the maximum number of distinct solutions. Okay? But we have our answer. Here are our zeros. Again, I like to go in order from smallest to biggest. So we have -5, -3, and then we have +2. And you have to state the multiplicity of each. So I'm going to say -5 with a multiplicity of 3 because it occurs 3 times. -5 with a multiplicity of 3. And then we have -3 with a multiplicity of 1 because it only occurs once. Okay? Then we have 2 with a multiplicity of 1 because it only occurs once. Okay, so that one was pretty easy because that one was already in factored form. Example 3, B and C are not in factored form, so what you're going to have to do is you're going to have to factor. Let me jot that down. Here we're going to factor. Factor. Example 3b has a GCF of x squared. So let's factor out the GCF of x squared. 0 equals x squared times x squared plus 6x plus 8. Then you're going to factor this trinomial in parentheses. What two numbers multiply to 8 and add to 6? The x plus 2 times x plus 4. Because 2 times 4 is 8, and 2 plus 4 is 6. Now think about it like this. X squared you can think of as x times x plus 2 times x plus 4. Now let's solve each one. X equals 0, x equals 0, x plus 2 equals 0, and then x plus 4 equals 0. That's going to give you -2, and it's going to give you -4. Now let's go to our answer. And again, I like to put them from smallest to biggest. So I'm going to say the zeros are going to be -4, -2, and 0. -4 has a multiplicity of 1 because it occurs once. -2 has a multiplicity of 1 because it occurs once. And 0 has a multiplicity of 2 because it occurs twice. On the next page, we'll talk about what this looks like on a graph, because eventually we're going to do graphing. By the way, notice when you add up all the multiplicities, 1 plus 1 plus 2, you get 4, which is the degree of that polynomial, degree 4. I've always said you could have a maximum of 4 different answers, because sometimes the multiplicity is more than 1. But when you add up all the multiplicities, it should equal the degree. Okay, here we go, last one. This one's going to have a GCF of x. Let's write it as 0 equals x cubed minus 10x squared plus 25x. And then let's factor out the greatest common factor of x, which will leave you with x squared minus 10x plus 25. See if you can factor. What multiplies to 25 and adds to -10? X minus 5 times x minus 5. Now set each factor equal to 0 and solve. X equals 0. X minus 5 equals 0. Or x minus 5 equals 0. You get x equals 0, you get x equals 5, and then you get x equals 5 again. So the zeros are the following. You have 0 and you have 5. 0 has a multiplicity of 1 because it only occurs once. And then 5 has a multiplicity of 2 because it occurs twice. Notice when you add up the multiplicities of 1 plus 2, you get 3, which equals the degree of that polynomial. Okay, so let's talk about graphing really quick, okay? And what multiplicities look like on a graph, okay? If you have a multiplicity of 1, it means the graph passes right through at whatever that root is, okay? Normally an x-intercept, the multiplicity of 1. Normally an x-intercept has a multiplicity of 1, I should say, or it occurs only once. When this happens, the graph simply passes straight through the x-axis. It occurs once, so it passes through and continues along with the normal path that it takes, okay? So you probably can't see this too well in the video, but that's -5 right there. Since it has a multiplicity of 1, it means it has a root or a solution at -5, and it passes right through. Okay? That's -2. If that were to have a multiplicity of 1, it means it just passes right through. And right here it has a root of 4, which means it just passes right through with a multiplicity of 1. So if a root has a multiplicity of 1, it just passes right through it. If you have an even multiplicity, if the intercept has an even multiplicity, meaning it occurs twice or 4 times or 8 times, etc., then the graph appears to touch the x-axis and then bounces off in the same direction it came from. Okay? The graph never passes through the x-axis. It simply touches it and it goes back. As multiplicity increases, the valley will become flatter and flatter. So that right there might be kind of hard to tell in the video. That's -4. Since it bounces off of it and it comes back, it means it has an even multiplicity. Okay? Whereas over here it has a multiplicity of 1 because it passes right through. Over here it has a multiplicity of 1 because it passes right through. This solution would have a multiplicity that's even. Okay? And last but not least, odd multiplicity, but not 1. Okay, we talk about multiplicity of 1. Odd multiplicity that's not 1. So if the x-intercept has an odd multiplicity, meaning it occurs 3 times, 5 times, 7 times, etc., then the graph kind of lingers around the intersection point before passing through. The graph does actually pass through, but it is sort of delayed before actually passing through, like in the image. As the multiplicity increases, the deflection becomes closer and closer to the x-axis. So for example, right there, that's -3. That would have an odd multiplicity. Maybe it's 3, maybe it's 5, maybe it's 7, but that's what odd multiplicity looks like. It kind of lingers at that point on the x-axis. We're going to do graphing later on in the unit. That's the last lesson, but this is just a preview to what graphing looks like based on multiplicity. Okay. And that's it for this lesson. This lesson was writing functions given zeros and the multiplicity.